Welcome to Ask IITians Learning. So this is me, Bhavya Agrawal, who has already delivered the entire lectures of periodic classification of elements to you. And in this entire journey of this chapter, we have discussed about what was the reason for the periodicity, how periodicity came into picture, then which all or who all were the scientists involved in the first developmental activity related to the periodic classification. Then we also discussed about the Dobbiners triads, the Newlands, Mendeleevs, and finally the modern periodic table, for which we devoted the greatest extent of our time, okay, and our knowledge towards learning of the modern periodic table. That's because it was the most crucial, and it is the most crucial, with only one drawback, that still the position of hydrogen is uncertain. Okay, rest every drawback was actually fulfilled. So it was a brilliant idea. After that, we came to trends and we discussed varied trends, that is about metallic character, non-metallic character, valency, size, right? We did many tricks. We did some Olympiad level stuff in our last class. So in today's class, again, as I've already gave you a hint in the last class, that we will be only discussing some higher grade versions in this particular class. It is not at all related to your NCERT level. Like in the previous session also, we had few topics which were above NCERT. So this entire class is above NCERT. So you won't find any of the things being written or mentioned in NCERT. Okay, so this is all high level, and yes, we will be trying to work it in the easiest possible way for your understanding. Okay, so let's see how it works. So the topics that we'll be covering in this session are electron affinity, ionization enthalpy, electronegativity, and oxidation state. Oxidation state, if I'm not wrong, you might have done in your chapter number 1 also. Okay. If not, then of course you'll be doing it here. So don't worry about it. So without wasting time, let's get started. So the first thing that we're going to start is the electron affinity. Now see, what do you mean by the term electron affinity? This electron affinity is known by varied other terms, that is electron gain enthalpy. This is another term for it. Or electron gain energy. Okay, these are three terms. Now, affinity means the tendency to attract something, or reactivity, sort of reactivity. Now, electron affinity means the amount of energy released when an electron is added to the outermost shell of an isolated gaseous atom. Now, what do you mean by this? See, whenever you talk about atoms, so you have seen that these elements have two kinds of tendencies, right? What are the tendencies? Either the element has a tendency to gain the electron or to lose the electron, right? These are the tendencies of an element, either to gain the electron or to lose, or maximum to share. Now, when the element is gaining the electron, of course it is happening in a way that the process is acceptable to the nature. The process needs to be acceptable to the nature, right? So now, when this electron is gained, Okay, it releases off enormous amount of energy, which shows that the process is acceptable by nature. Okay, this is just a way of showing it. All right. Now, in which sort of element can the electron be added? So your electron can be added exclusively, the electron can be added exclusively in an isolated gaseous atom. That means, suppose I talk about chlorine. So you know that chlorine is present as Cl2 as a diatomic molecule. Now, to this diatomic molecule, you cannot add the electron. That's not acceptable by nature. So what is acceptable by nature? So the thing is that you have to add an electron exclusively to the isolated atom. Isolated means single atom. And when this atom is present in its gaseous state. Now, when this sort of species is there, you know that chlorine is having an electronic configuration of 287. You have already done this in your metals and nonmetals chapter under ionic bonds. Right? So in this 287 part, when it gains an electron, when it gains one electron, so chlorine becomes chloride ion. And now the new electronic configuration is 2,8,8. Right? So this leads to the amount of energy released when an electron is added to the outermost shell of an isolated gaseous atom. Now, when you are adding this electron, so addition of this or the tendency of this element to add this electron, that tendency in mathematical term is known as electron affinity. It's known as electron affinity. So now, what do you mean by mathematical term, or why do you need that? That's because suppose you are a brilliant child. Okay, you are a very hardworking child. Okay, your parents say that you are hardworking and you can do you do a lot of studying. Okay, but then a lot of study, is this a quantized term? I do not know. A lot of study, what does that mean? Like for me, it could be 3 hours. For someone else, it could be 5 hours. It could for someone else, it could be 8 hours. Right? So we need to quantize something. We need to put it as a value in terms of numbers to do the comparison. So whenever you have any property, okay, any tendency, any property, any efficiency of yours, so that efficiency cannot be calculated precisely until and unless you can give it a numerical term. By then, you can easily compare it, right? So no matter whether Volta's a career or like Hitachi, they say that we have the best ACs. Okay, no matter who's coming into the league and who's claiming what do you see? What do you see? You see their star ratings. Yeah, nowadays everyone sees the star ratings. Okay, everyone goes and checks the star ratings. Whenever, whatever you are trying to buy an AC, a fridge, a washing machine, you're going to do that, right? Be it Bosch, be it Calvinator, be it Whirlpool, whatever you ask for. You just check the star ratings. So what do you do with that? If something is 5 star or 4 star, you know the comparison. Otherwise, were you able to do the comparisons that way? So the numbers will give you an easier comparison. And that is why these numbers are very important. So that will help you to understand that which element can easily attract an electron and which element won't attract the electron that easily. Right? That's the only reason. That's the only reason. So how does this trend work? You know that non-metals have a tendency to attract the electrons more easily, right? Non-metals have a tendency to easily attract an electron. So the electron affinity or the electron gain enthalpy, I can say, increases across the period. Yeah, because the tendency of the element, they have a tendency to act as a non-metal, and non-metals have an easier tendency to attract an electron. They can easily gain an electron. So their tendency to do so, their tendency to attract an electron or to gain an electron, increases across the period and decreases down the group, right? And that's because the metallic character increases down the group. Make sense? Yes? Correct. So this is how the trends work. Now we have another trend that we are going to talk about. Just like electron affinity, we have an opposite trend, that is your ionization enthalpy, also known as ionization energy. Now, okay. Now, what actually happens is when you talk about your ionization enthalpy or ionization energy, see, you know that whether you're talking about gaining the electron or you're talking about losing the electron, no element will do it just like that. And like I took an example of your phone. So suppose you are holding your phone and someone asks you to give away your phone. Will you just give it like that? No. You'll have a fight, you'll have a quarrel, the person has to apply some force to snatch that phone away. Right? Same is the case of metals. No matter metals are electropositive, they can easily lose their electron. Doesn't mean that they do it willingly. Okay? You have to give it some force to do that. Right? So ionization enthalpy is the energy required to knock off or remove the outermost loosely bound electron. Energy required to knock off or remove the outermost loosely bound electron from an isolated gaseous atom. Just like electron affinity, I need the atom to be present, or the element to be present in, first of all, isolated state. That means a single atom should be there. And that atom needs to be present in the gaseous state, right? So for instance, I'm talking about sodium. Now, sodium is having an electronic configuration of 281. It can lose an electron, but it won't lose just like that. I have to snatch that electron. I have to pull that electron out, right? To remove that electron out. So in order to remove that electron, I have to give it some energy, right? I have to give it some energy. So suppose this is your atom, like this is your sodium atom. So this is the additional part, this part. This is the cap. I have to remove it. But can I just, if I'll ask it to, okay, cap, just remove yourself. Not getting removed. So what do you have to do? You have to pull it out, right? Now the electron is ejected out. It's out. In that atom, now this electron no more exists, right? Now, in order to remove that, what I had to do? I had to apply some energy. Even when I'm trying to put it back, I have to give some energy. See, This is not put. Yeah. So in order to put it, I have to give some energy. I have to remove it again. So now what is happening? What is happening? What is that energy which I need to give to remove that electron? That energy is known as the ionization enthalpy or ionization energy. Okay. So when I give that energy, now that electron is removed off and the new electronic configuration is this, and sodium gets a positive charge. So with the help of ionization enthalpy, like that is only working for electropositive elements because I'm trying to remove the electron, making that element positive in nature, right? Make sense? A cation. Now, suppose, like I'll take an example. Suppose I have calcium. Okay. So calcium is 2882. Now I give some energy, okay, and I remove one electron. So basically, whenever I provide an energy, it's a chain process. Okay, so it happens one by one. So one electron is removed out. One electron is removed. Now I have to provide more energy, some other energy. So when you remove one electron, that energy is your ionization energy 1. When you remove the second electron, it is the ionization energy 2. So that is Ca2 plus 288. And now the outermost shell is completed. Now in this, what do we observe is that it is the IE2 which is having which requires more energy. IE2 is having greater extent of energy as compared to IE1. If I talk about mathematically, magnitude wise. So the value of IE2 will be more than that of IE1. This is known as successive ionization enthalpy. So it is always that the successive ionization enthalpies like IE3, IE4, they are more than the previous. Now the reason being that if you try to remove an electron from a cation, don't you think it would be a tedious task or a difficult task? Previously, you were removing the electron from a neutral element. Now, I am not saying that it was an easy task. No, it wasn't. But still, you were trying to remove an electron. Like suppose you in your plate, you got all the food. Okay, you were in a party. Okay, and you chose your food very specifically in your plate. Hmm. You took all the good food for yourself. Let's say if I had to prepare my plate, I'll be taking few portions of paneer tikka, few portions of pasta, few portion of or some portion of pav bhaji, some portion of some other things. Okay, a pizza piece and all that. Okay, so I'll be putting all that. Now suddenly someone comes. Okay, while talking to me, they ate my pizza piece. I'll be highly furious on that guy. The moment that person took my slice, I'll be furious. Okay, but then it's all right. Okay, I'll get another one. Suppose that person comes again. What will I do? My first thing will be I'll put a barrier, thinking that you are not allowed to see my plate. Otherwise, you will definitely take the slice away. So that would be our first step, right? But this time the person has to do more effort to get the slice because the slice was not comparatively easily available. Previously, when the person was taking, I might have said, okay, no, please don't. And he's like, oh, you get again. But the next time I'll be like, no, you can't have. Okay, I know you will be taking it. I'll keep my plate away. So this is the case with calcium. So it's a positively charged. It's a cation. So cations will obviously hold the electrons more tightly. So as a result, it would be even difficult to remove this electron. And that is why all the successive ionization energies are will be having greater values as compared to the previous ionization energy. Got it? Yeah, makes sense? Perfect. So the trend will be easy. What is the trend? Now, if you talk about along the period, the ionization enthalpy will increase. Why will it increase? Because your size decreases along the period. Now, if the size is decreasing, it means the outermost electron is closer to the nucleus. If it is closer to the nucleus, it is having stronger attractions. So it becomes difficult to remove that electron. Whereas down the group, what is happening? The size increases, which means the electron is away from the nucleus. If the electron is away from the nucleus, I can easily remove that, right? If I can easily remove, then what happens? The ionization energy value decreases. So the energy which I have to give to remove the electron will decrease. Make sense? Everyone? Okay. Now about electronegativity, we just discussed it in the previous slide also, the previous class. Okay. So electronegativity refers to the ability of an atom to attract the shared pair of electrons. If you remember, I said this line. Now, what do you mean by the shared pair of electrons? And how is it different from electron gain enthalpy or electron affinity? Because even that was attracting the electrons, right? This is also attracting the electrons. So what is the difference basically? So we already know the trend that nonmetals have a tendency to pull the electrons more, and that is why it increases along the period and decreases down the group. Because along the period, the non-metallic character increases, but it decreases down the group. So electronegativity also decreases. But what do you mean by the term attract the shared electrons? So basically, you know about a covalent bond, right? So what you have done probably is about H2, N2, and those kind of simple cases. Okay, so suppose you have a hetero suppose we have a heteronuclear diatomic molecule. Right. So now what do you mean by the term hetero? Hetero means different. Right. Nuclear means nucleus. Di means two. Atomic refers to atoms in a molecule. So if I have a molecule which is made up of two atoms and the two atoms are having different nucleus. Example, HCl. Okay, so I'll better take this example over here. H and Cl. So whenever you talk about the Lewis structures, what happens? You have this electron cross dot structures or electron dot structures. So what do? You just write the symbol of the element along with its valence electron. So hydrogen has one valence and chlorine has 7. Then there is mutual sharing. And mutual sharing means like if hydrogen is giving 1 electron, chlorine also has to give 1 electron. Exact, equal sharing. So they are sharing the electrons. Right. Now by sharing the electrons, they have made a bond. They have made a connection. So that connection is basically, since this connection is based on the sharing of electrons. So we call it as a covalent bond. And during this sharing, only a single line is formed. Single bond is formed. So we call it as a single covalent bond. Right? Now in this, chlorine, as you know, along the period, the electronegativity increases. So chlorine is more electronegative. But technically, when a bond is made, okay, now because it is equal sharing, so it means the two electrons will lie equally or at equal distance from one another, from each of the element, right? Or I can say that each element has an equal access to these electrons. For instance, suppose, okay, suppose hydrogen is a person, like they both are having lunch together. Hydrogen and chlorine are having lunch together in their school, right? Hydrogen by chance bought rajma that day, and chlorine only bought rice that day. Okay. Now, when they started eating food, okay, they opened up their lunch, and what they found is that hydrogen was only having the rajma, whereas chlorine was only having rice. Now, when they sat together to have their food, what they realized is that when they kept their food on the table, so since they were friends, they had this tendency to share the food among themselves, right? So while they were sharing the food, hydrogen had the excess both towards rajma as well as rice. Same way, chlorine was also having access towards both rajma and rice, right? They both have equal access to both the things. Make sense? So as a result, what happened? Since they were having equal access to it, so now I'll say that the food was kept somewhere in between. Or if someone else is passing by, can you, if you were going roaming around, can you identify while the two people are having food that who bought which part? You can't. Even if when you go for a picnic or you go for somewhere, okay, if there is a place in which multiple families are there and they have opened up their things, so you cannot tell that which family brought what food. You cannot. Since they're eating together, that cannot be identified, right? So again, that one electron represents Rajma and the other electron represents rice. So it means the two electrons again cannot be identified as an individual electron of hydrogen or chlorine, respectively. You cannot do that. It belongs to both of them, and they both have equal access to it. Right? Now, what happens? When one of the element is stronger, okay, when one of the element is stronger, what happens? Let's say chlorine. So chlorine is more electronegative. Since it is more electronegative, it will have a tendency to pull the electrons towards itself. Right? Now, as a result, these electrons, which were previously equally shared among hydrogen and chlorine, were now a little shifted towards chlorine. So that's because of its strength. Right? That's purely because of its strength. Okay? So hydrogen and chlorine, in that, since chlorine is more electronegative, it will pull the electrons towards itself. So this is just like that out of like hydrogen and chlorine. Suppose hydrogen ate less food. So what will happen? Eventually, chlorine will put both the rajma and rice towards itself and start eating. Okay. So what happens because of that? So this portion or this part of attracting, what has chlorine done? Chlorine has attracted the shared pair of electrons. It has attracted the shared pair of electrons in a covalent bond. So in a covalent bond, the equal electrons are equally shared. What will chlorine do? It will attract the electrons. Shared pair of electrons means the bonded electrons, the electrons which are participated in bonding. It has attracted that. So, whereas if you talk about electron affinity, what happened? It was the tendency of an element to attract an electron, and because of which it becomes a pure anion. यहाँ पर it will just attract the bonding electron. Individually, it is not attracting. So, it is not attracting in the atomic state. So, electron affinity is given for atomic state, whereas electronegativity is given for molecular state. And that is the difference between the two. Got it? Understood? All right. So now let's move to the next part, and that is your oxidation number. Now, what is the oxidation number? So, oxidation number is basically a kind of a formal charge or an arbitrary charge which an element will get when the other elements are removed in the form of their ions. When you try to remove the other elements in the form of ions. For example, I have a molecule H2SO4. Let's start with a simple one, NaCl. Now, in NaCl, what is happening? You know that sodium has a positive charge, Cl gets a negative charge. So that is their oxidation states, or basically their true charges. So these are their formal charges. But suppose I talk about a molecule which is a covalent molecule, sulfuric acid. Now, in that, what will happen? There is no charge. So I have to find out, let's say, the oxidation state of sulfur. The simple definition is that oxidation state is the arbitrary charge or the left out charge when the other atoms are removed in the form of their ions. So what are the other atoms? Hydrogen and oxygen. So if I remove hydrogen in the form of ion, hydrogen generally is H plus. And what is the tendency of oxygen? To gain 2 electrons. So when it is removed as ion, it is removed as O2 minus. Right? Now, if you look at the overall molecule, how many hydrogens do I have? 2. Right? And each hydrogen has a charge of +1. So the total charges contributed by hydrogen atom is 2 into +1. Same way, when I talk about sulfur atom, I do not know what is the charge contributed by it. So let the charge be X. Now I talk about oxygen. So about oxygen, I know that each oxygen has a tendency to attract 2 electrons, right? And I have 4 such oxygens. So it would be 4 into -2. And so if I add all the charges of the atoms, it will give me the overall charge of the molecule, right? And overall charge of the molecule is what? 0, because it's a neutral molecule. So the overall charge is 0. So from here, I'll get a linear equation, which is 2 plus x minus 8 is equal to 0. From here, I'll get x as +6. So that is the formal charge or the arbitrary charge which sulfur gets in this molecule. And it is this charge which is your oxidation state. This represents the oxidation state of sulfur. All right. Yeah, makes sense? If yes, then can you quickly find out what will be the oxidation state of phosphorus in this molecule? Considering that H will be +1, O is -2, and your answer will be +5. So you know 3 into +1 because of hydrogens, plus the charge contribution of phosphorus, let's say be X, And the charge contribution by oxygens, which are 4 in total, it's 4 into minus 2, and the overall charge in this molecule is 0. So it is 3 plus x minus 8. So x comes out to be plus, which is your oxidation state. So there are some common oxidation states or oxidation numbers which are given for multiple groups, okay, as identified here. All right. So that finishes off your complete theory for this particular chapter. And this is the last part of the chapter. So now we are done with all the chapters of grade 10 and the entire theory of grade 10. So this is wonderful, isn't it? We're done with it finally. Now you're all set for your board examinations and the revisions. So do work hard towards it, right? But before we end up the class, let's have some quick questions. So the first question is, how does the electronic configuration of an atom related to its position in the modern periodic table? The electronic configuration, right? So you have done it now, I think, many times, that when you talk about the number of valence electrons, which comes out of electronic configuration, right? So that from the electronic configuration, you will find out the valence electrons, and it is the valence electrons which decides the position of an atom in the periodic table. Where exactly will that element lie? In which group, in which period? Because in the electronic configuration, the number of shells will give me the period number, right? And the valence electron will help me to identify the group number. So basically, it is with the help of the electronic configuration that I can find out the position in the periodic table. And that is how the things are related. Right? Yes? Good. So see, that was a very simple question, and that is all about today's learning procedure. Okay, it was great having you as an audience. And whatever are your doubts, if you need any sort of help, you know that batch discussion forum, I'm available on WhatsApp and I'm available via DRS as well. Okay, so you can always ask for that. Okay, so that's all for everything. Bye bye. Take care. Good night.